What's up, calculus students? Last big homework. I'm going to start reviewing for the final. Have some tiny homeworks. Reviewing Unit 8, just little flavors of Unit 8, questions you might have seen in the past. Starting with the accumulation function, understanding equivalent forms. This would be super f of x minus super f of 0. I don't really have super f, so I'm not going to use this. However, it is easy enough to then see the derivative of the accumulation function is just regular f. So k prime is f. Cool. Same thing can be done with g. You have 2x plus super f of x minus super f of negative 3. Probably wouldn't use that because we don't have super f. But we could see g prime would be the derivative of 2x plus the derivative of super f minus the derivative of super f of negative 3, which is a number whose derivative is 0. Here, the equivalent form would be super f of x squared minus super f of negative 5. Now, this again is not used, but it is helpful to see because the derivative is regular f of x squared times 2x minus 0. Whereas j, it is helpful to see that we have f of x minus f of 0. Accumulating the derivative, changing the original, antiderivatives, fundamental theorem of calculus. So that's always good. It's always good to have that. All right, let's answer the questions. Critical points of k. K's critical points are when its derivative is equal to 0. I will write that k prime is equal to f, so I'm looking at when f equals 0. I have x equals negative 3 and x equals 2. Are these locations of relative max min or neither? I would say x equals negative 3 is a neither. I'd say x equals 2 is a max. Why? I'm going to write out all of the signs of my derivatives, and I will be fine. Whenever you are justifying, it's always safe to just include all of the signs of the derivatives everywhere. You would say k prime, which equals f, is greater than 0 from negative 5 to negative 3, and from negative 3 to 2. You've already said that it's equal to 0 there. And you say k prime equals f is less than 0, is negative from 2 to 4. Cool. Find the x locations of points of inflection. And how did I answer this? I'm talking about looking about k going up or down. That's looking at k prime, positive, negative, positive. K prime equals f. This is the graph of k prime. Points of inflection is when g's concavity changes. G's concavity is changing when g prime's direction changes. It's got a max or min. G double prime is positive or negative. We see g prime is equal to 2 plus f. G double prime equals f prime. Okay, I want to figure out when f prime's direction changes. Well, this is f. F prime is negative, then positive, then negative. This is a bad question. Oh, wait. Science. G double prime, which equals f prime, or g prime, which equals 2 plus f, its direction. Yeah, it is easy to see when g double prime's sign changes. Goes from negative, positive, negative, or you could say this is when 2 plus f, which equals g prime's direction changes. So that's going to be x equals negative 3, x equals 0. I would say that g prime, which equals 2 plus f, has a max or a min, which means its direction changes. Find the minimum value of k. Okay, first thing I should do is know that I'm looking at the derivative equal to 0. Cool. I would then say, and I would do an assign analysis of k prime, which equals f. It's positive, negative, sorry, positive till it hits a 0, then a positive, and then negative after that, which means K is increasing, increasing, decreasing. I would say that K of -5 or K of 4 are my possible mints. I would say that because of the sign analyses here. I would repeat down here. I need to find the values. So let's find K of -5. It's the integral from 0 to -5 of f. Going backwards, so I'm not using super f. Rather, I'm saying accumulate f using geometry, which is something I can do. Going backwards is the opposite of going forwards. This homework video is going to take forever. So I find this is +2 if I'm going from left to right. I see this 1, 2, 3, 1, 2, 3, 4. So this is 6. So K of -5 is -8. And then K of 4 is going to be the accumulation from 0 to 4, which will be a +4 and a -4, which is 0. There's my winner. Great. All right, J of 4, J prime of 3, J double prime of 3. Let's do it up here. I would have f of 4 minus f of 0. F of 4 is -4, f of 0 is 4, so that'd be a -8. J prime is equal to f prime. J prime of 4 equals f. Is that what I want? 4? 3. 3. J prime of 3 would equal f prime of 3. F prime of 3 is the slope of this line segment, slope of f, down 4/2, -2. And then J double prime of 3 would equal F double prime of 3, which would equal 0 because there's no concavity. We're not concave up, it'd be positive. We're not concave down, it'd be negative. H2, H prime 2, H double prime of 2. Great. H of 2 would be the accumulation from -5 to 2 squared, which is 4. All right, so from -5 to 4, I'd have this positive areas, total positive, and then that negative. So that would be 8, +8. Okay, H prime, if you need help understanding why this is f of x squared times 2x, it's a chain rule, it's an outside and an inside. H prime of 2 would equal f of 4 times 4. F of 4 is the point, -4 times 4, which is -16. H double prime, that sucks. I don't want to do that. But we'll do it. I'll write it down here. If H prime equals f of x squared times 2x, right? Yeah. Watch this. H double prime. Product rule. Yeah, none of you are getting this right. You got to pay attention to all the details. Slopes of the first times the second plus the slopes of the second times the first. H double prime of 2 would equal f of 4 times 16 plus, oh f prime. Slopes of the first times the second plus the slopes of the second times the first. Okay. So f prime of 4, I would call -2, but not really. F of 4 is -4. None of you are getting this right. This would be a good challenging problem. All right, you had this on your test. We had real world situations. We have a position, P, which is in hundreds of spores. We had S, which is a rate of change, spores per hour. Accumulating S would give you change in P. It would give us total spores added or something like that. We need to either find C or be able to go backwards. Estimate the rate of change of spore population at time 2. This is when we are going to look at the average rate of change of P over the interval 1 to 3, which will be 30 minus 20 over 3 minus 1, which is 5. I'm taking the derivative of P. I get P prime. I'll get spores per hour. That's my units of measure. That's my answer. Must there be a time when P prime equals 8? I don't think it's supposed to be 8. I think it's supposed to be 15. Why don't we call it 2? Cool. The mean value theorem says that if P is differentiable, which it is, all you have to do is find an average rate of change on an interval that equals 2, and you're guaranteed to have an instantaneous rate of change. The mean value theorem is AROC equals IROC. AROC over an interval equals IROC over an interval. So since P is differentiable, I'm going to say that the average rate of change of P of T over the interval 3 to 5 equals 2. Therefore, by the mean value theorem, P prime of T must equal 2 for some T. Run an expression involving an integral that can be used to find the average amount of spores in the Petri dish. Okay, so we will accumulate P to get a super F, which will be spores times hours, but then we'll divide over my interval to get average spores. So I need to accumulate my spores, but then I'm going to divide over my interval because this will be spores times hours divided by hours to go back to spores. Use a left Riemann sum. Left Riemann sum says base times the left height, so that'd be a 1 by 5. The next would be a 2 by 20. The next would be a 2 by 30. And I'll divide that by 5. This is in hundreds of spores. And is my approximation over or under? Well, I'm using a left Riemann sum of an increasing function. If you use a left Riemann sum of an increasing function, you are going to be under. So this is under approximation because you're using a left Riemann sum on an increasing function. It's not because it's concave down, just because it's increasing. Trapezoids, that. Find S prime of 6. Well, S is already a derivative, so S prime would be the derivative of a derivative. It would be a rate of change of a rate of change. It'd be a spores per hour squared. It would tell me how my rate of change is changing. Let's write down S of t. Cosine pi over 2 t plus 12 over t minus 4. S prime, I have to use the chain rule. I got O's and I's. I'll have pi over 2, make it negative, sine pi over 2t. That's an O and I. Outside's cosine's derivative is negative sine. Inside's derivative is pi over 2. And then I got to take the derivative of 12 over t minus 4. You can use the product rule, the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Or you could rewrite this as 12t minus 4 to the negative first. O and I it, you'll have negative 12t minus 4 to the negative second times 1. Cool. S prime of 6 would equal negative pi over 2 sine of 3 pi plus negative 12 over 6 minus 2 squared. That gives us negative 3. This would be spores, hundreds of spores per hour squared. It tells us that the rate of change of spores per hour is decreasing. The rate of change is negative. I'd say the rate that spores are changing is decreasing. 3 spores per hour. Rate of change of the rate of change. Cool. Find the exact number of spores in the petri dish at time 8. Well, I'm only using S from 5 to 8. I've used P from 0 to 5. We need to understand that P of 5 is 34. Great. We need to understand that we would only be able to accumulate S from 5 to 8. This would give us how much we've added. We would have this number plus that. We need to use super S. Super S is essentially P from 5 to 8. We need to take the antiderivative of S. I'd have a positive sine pi over 2t, but I need to undo things with the 2 over pi. And I'd have a natural log, 12 times the natural log of t minus 4. There's a plus c, but I don't have to worry about it. I just need super S of 8. Don't simplify unless you really want to. And then I'm going to plug in 5. The c's will cancel. This is a 0. This is a number. This is 2 over pi. This is 0. This is my answer. This is my, P of 8, essentially. Cool. Okay. New stuff. Spinning. Trying to do the answers without a calculator. Let's get the answers with a calculator and then try not to get them with a calculator. Okay. Here's the concept. Okay, we are going to take this region that's under 9 minus x squared. We're going to spin it around y equals 0. We create this three-dimensional object. It's a solid object. Okay? Great. There's no hole. It's super solid. Can I zoom out a little bit? There you go. Great. How do we find the volume of the object? Well, we actually think about a rectangle. We spin a rectangle that's very skinny. Here's the example of a rectangle. Now, when I spin this rectangle, I create a cylinder. Do you see it? It looks like a line. There it is. There's a cylinder. Now, you can see the radius would be this length from the top to the middle. You can see the height of the cylinder is a small x distance. It's very important to see said cylinder. Because if you take that volume of the cylinder, great. you can take an infinite amount of these cylinders. You can take it from the start to the end, use the idea of a integral as an accumulation, accumulate all the volumes and you win. Well, the idea behind taking a skinny rectangle and spinning it to create a skinny cylinder is important. We would understand that the radius of said cylinder would be what we've talked about as the height. I would say h 9 minus x squared can be considered a radius. We could see that the height is this small x distance, like the depth of the circle or the cylinder. I want to sum up my volumes of my cylinders, which is pi r squared h. Call r h, sum it up from use your pencil, x equals left to an x equals right. I'm going to go from x equals 0 to x equals 3. Great. If you have a calculator, you could type this in this way. We did this same example. You could say, well, my height is 9 minus x squared minus 0. Y equals top minus y equals bottom. I could sum up from 0 to 3 pi h squared dx. You could also say r equals h. I don't think they like that. You could say r equals h. You could say, let's sum up my pi r squareds. H's. Get the same answer. Kind of moving with the h or the r. I don't care. Whichever one you guys want to use. As long as you understand that height becomes a radius of a circle. Now, what if I wanted to get this answer without a calculator? Well, I'm going to need r squared. This guy shows up again. And I'm going to need the antiderivative, big R squared. So I'd have pi big R squared of 3 minus big R squared of 0. You could say volume, and this is big V. There's so many different ways to do this. So I'd have 81 times 3 minus 6 times 3 cubed plus 1/5, 3 to the 5th. The key is you have to simplify this, minus 0. You have to simplify your R squared. Honestly, don't care. Like if you do all of these, as long as you get the numerical answer, 407.150. Watch how I can get that answer by doing pi 81 times 3 plus minus 6 times 3 cubed plus 1/5, 3 to the 5th, and I get that same answer. Okay. If I spun this around the y-axis, okay, I can see, since I'm spinning it around the y-axis, I'd probably want to think about using a horizontal rectangle that's spun. The dimensions of that horizontal rectangle is a width and a height, w dy. That's like taking doesn't like spinning it like using a horizontal thing. Yeah, no. You get it, but I can't give you a rectangle from like 1.1 to 3. So we got to just visualize it. take this cylinder, put it on its side, we could see that W now is an R. Cool. W is an x distance. Solve for x. X squared equals 9 minus y. X equals root 9 minus y. Cool. I would like to sum up my pi W squared. It's R squared, W squared, whatever you want to do. But now it's got a skinny height dy. I'm going to go from a y equals bottom to a y equals top. Great. You're going to say W is an x equals right minus left. And you're going to get the answer. I'm not going to do it without a calculator, though I could. Actually, it's easier. I would say you can use W, you can use R, I don't care. You could say R is equal to that. You see that it actually gets you a different answer, which is interesting. Let's go from 0 to 9 of pi W squared dy. And W is square root 9 minus y. Great, 127.12.234. But to get the answer, you would need super W squared of 9 minus super W squared of 0. And you need a super W squared. So first we're going to get W squared. W squared is just 9 minus y. Super W squared is actually easy. It's 9 minus y, 1 minus 1/3 y plus c. So it's actually an easy answer to get because you get 81 minus 27 divided by 3, which is 9, minus 0. So we actually get 27 divided by 3 is 9. 81 minus 9 pi. 72 pi? Let's see. 72 pi. Now, what did I do? Oh, sorry. 1/2 y squared. Cool. So 81 minus 81 halves, which is like 40.5 pi. Well, bam. Okay. I'm going to just go. Well, I am going to show you how to do these without a calculator, but let's try to get the answer with a calculator. Spread around the x-axis. Spread around the x-axis. It's going to come down here. Cool. That being spun, great. I have the dimension of this rectangle, which is a height and a dx. The height ends up being a radius. You could do that. That's great. Height is just root x. So we could say r is just h. Cool. I will sum up pi r squared depth from 0 to 9. Okay, well, if r is h, r squared is x, I could say super r squared of 9 minus super r squared of 0 would be super r. It's 1/2 x squared plus c. Be 81 halves minus 0 pi. I'll say h is that. Say r equals h. I will sum up from 0 to 9 pi r squared h. 127.234, which is the same answer as what we got earlier. Cool. Okay, but then we look at this next one. I'm spinning this around the y-axis. We have our first hole. Once you see a hole, alarm bells should go. Because let's look at something that has a hole. Okay. Let me take this rectangle and spin it. Oh, yeah, that doesn't work. Spin it. Look. What is created is what's called a washer. It's got a cylinder with a hole on the inside. Now, the volume of this washer is not as simple as pi, whatever this length is, this is a height, pi h squared dx, it's not correct. The volume of a washer actually can be thought of as a volume of an outer cylinder minus a volume of an inner cylinder. We have an outer radius squared, which we'll subtract by the inner radius squared. Usually the top, usually the bottom, not always. It's all about bigger radiuses minus smaller radiuses. Understanding this bigger radius versus this smaller radius. If you factor out a pi, you'll have an r squared minus an r squared. It's not as easy. It's not just h's dx. It's not just h squareds. We have to separate the h. So, if you think about this being spun and it pops over here, great. But the volume of this shape, which is this washer, this flat cylinder with a hole in it, the volume of that washer is pi, bigger radius is squared minus smaller radius is squared, times dx or dy. Well, you need to think about where would your radiuses be centered, right here. The outer radius always goes, and you can put your pencil down. You can say, okay, my outer radiuses always go to x equals 9. I'm going to call my outer radius x equals 9. My inner radius will always go to x equals y squared. My inner radius will always go to y squared. I would like to sum up from a bottom to a top. Horizontal things like to go from a bottom to a top. A pi, bigger radius squared minus a smaller radius squared. You could call it a bigger w minus a smaller w. You could do a right squared minus a left squared, though we have to pay attention to it. But I would literally type in to my graphing calculator, and I'll do it over here. That my biggest radius is 9, that my smaller radius is y squared. And I would sum up from 0 to 3, pi, my bigger radius is squared, minus my smaller radius is squared. dy, because that is the dimension, that is the depth of it. So I get 610. I'm going to use my calculator. I'm using my calculator for the rest of the home. You can think about it as two integrals, and you could do it with two integrals if you wanted to, but it's best to understand it's a washer. That rectangle spun has its own unique formula. All right, I'm going to go get lunch, and then we'll continue. Okay, we're back. We now are spinning these regions, and they're all going to have holes. Okay? We might be spinning them around an axis, x-axis, y-axis. It might be around a line, which we can consider an axis. If I spin this region around the x-axis, I immediately notice I got a hole. Hole brings up bells and whistles. We have not a cylinder, but a washer, which means I have outer radiuses minus inner radiuses squared times our depth, dx or dy times pi. It's got to be in parentheses. What it's not a top minus bottom squared. It's not an h squared. It's not. Okay. So, advice. See the region, what it looks like when it's spun. Advice. See the rectangle. Yes, it's got a height, and yes, it's got a dx, and that helps me go with dx. But instead, think of it as outer radiuses, big R. The big R goes to the y equals root x minus 1. And inner radiuses, smaller r. The smaller r goes to the bottom y equals 1. Sum these up from an x equals left to an x equals right. I'm allowed to use Desmos, so I would be able to figure this out. This would be x equals 10. This is x equals 1, 2, 2. This is y equals 1. This is y equals 3. Double check that by graphing, but you should be able to see. That region. There you go. 2, 1, 10, 3, 2, 10. Okay, cool. So, since it's a washer, since we have a hole, don't do h squared. Don't do top minus bottom squared. It's not r squared. It is outer radius is squared minus inner radius is squared times the depth dx. We're cool with that. We just need an expression for our big R and our small r. Square root x minus 1. 1. 2 to 10. Dx. 100.530. Units cubed. Spin around the y-axis. Pops over here. Sure, you have this rectangle that has a width and a small height. That's good. However, since we have a hole, we are not talking about a cylinder. We're talking about a washer. Take the volume to the outside, subtract the volume to the inside. The volume of the outside is pi bigger r squared h. The volume of the inside is pi smaller r squared h. Factor out the pi, factor out the h. We have pi outer radius squared minus inner radius squared h. Cool. Visualize what is the outer radiuses. It's the x equals right in this situation. That's x equals 10. Visualize what are the inner radiuses. The inner radiuses are this x equals distance. This x equals distance is y squared plus 1. If this is a multi-part question, you do have w. And w is going to be 10 minus y squared plus 1. But when we spin, we don't use w. We use different parts of w's for our different radii. Sum these up from a bottom to a top. The bottom is y equals 1. The top is y equals 3. Outer radiuses were x equals 10 consistently. Put your pencil on the paper to understand. The inner radiuses was y squared plus 1. dy. 415.527. I mean, I honestly want 2 of them here. Cool. So you can see that this one doesn't work if we have x equals y's. $415.527. Okay, now this gets harder. Spun around the y equals 5 line. This is 2, this is 10, this is 1, this is 3. This is y equals 5. Okay, if I spin it around, y equals 5. We would think about this rectangle that has a height and a width being spun around. Okay, cool. That helps me understand that I'm going to have dx. But since we have a hole, we need an outer radius squared minus an inner radius squared. Not a top minus bottom quantity squared, not an h squared. So we have h, but we actually don't use it. We instead will use it for other questions. H will be used for other questions. Instead, we think about the radiuses. Now, this is a tricky. What is the radius to the outside? Well, I can see this outer radius is this y distance. It's a y equals top minus a y equals bottom. The outer radius here is a y equals 5 minus a y equals 1. The outer radius is 4. Consistently to the outside, we have this outer radius of 4. The inner radius, think about this length here, which is the inner radius of our spun guy. The inner radius would be y equals 5 minus y equals root x minus 1, top minus bottom. So I understand y distances, y equals top minus y equals bottom. Here, that line that we're spinning around is the top and the bottom. So I'm going from 1 to 3. My outer radius was 4. My inner radius was 5 minus root x minus 1. And I get 192.684. Summing this up from 2 to 10. dx. $192.684. If I spin this around, x equals 11. All right. So we're spinning it around this line. It gets reflected over here. We see that we would use this rectangle that has a width and a height. But when I spin it, it's not a proper cylinder. It's a cylinder with a hole. We have a hole. We have a washer. We have a cylinder with a space in the middle whose volume is outer radius squared minus inner radius squared pi. Cool. I'll sum these up from a y equals bottom to a y equals top. I'll have outer radius squared minus inner radius squared. Now I just need, and I got dy as my depth. Now I just need an expression for outer r and inner r. Well, since I'm spinning around this line, this would be kind of the center of the cylinder or the washer. I can see it's this x distance, which is an x equals right minus an x equals left. The x equals right is the middle, is the line we're spinning around, x equals 11. The x equals left would be x equals y squared plus 1.
Now you got to do 80, 60. 80, full reset.
If it hits the
If the
gauge,
opposite-
it's just a 60.
It's 60, yeah. If you have
60.
Possession.
It's 80. That's a big thing.
I think like the NBA does that too, right? They go,
They go to 14.
Yeah,
Yeah, 14, 24.
Yeah, so it's
Inner radiuses.
But
What
you
are
need
these
two
inner
statements.
radiuses?
80, 60.
Yeah.
That's not many shot clock operators.
Yeah.
The inner radiuses are always going to be 11 minus 1. The inner radiuses are always going to be. Cool. So if I change my outer radiuses to 11 minus quantity y squared plus 1, and the inner radius 11 minus 1, I get from 1 to 3
Just look at me.
a mistake. Why did I make this mistake? Y squared plus 1.
So you're kind of driving the week. I know that you're kind of the week.
Yeah.
And when you got Monday and Tuesday off, are you going to pay for it?
I feel like I'm going crazy.
Uh-oh.
11 minus y squared plus 1. Y squared plus 1. X equals right minus x equals left. Outer radiuses 1 to 3. Check. Oh, stupid. 11 minus 10. That's 1. Now we got 229.545. 11 minus 10, which is 1. 229.545. Okay. Got a couple more. We have to go to chapel.
Good job. You got time to do one more.
I gotta find like all these intersections. All right, let's find the intersections. Let's go. E to the, we've done this one before. I'm gonna reset. Pretend like you're resetting. Pretend like this is a completely new problem. You got e to the x over 2. You got 2x plus 1. We got an intersection. We'll call it an A and a B. We got an intersection. It's a C and a D. Make sure you understand which one's which. We go A's an X, C's an X. So I'm going for A to C sometimes. And I'm going to go from B to D sometimes. Write down those numbers for your tests. Pause. Let's go to Long Chapel. Monday, Thursday on a Wednesday. Is that what they say? Monday, Wednesday, Thursday? Monday, Tuesday, Thursday, Wednesday. Oh, I'm back. Where was I? Okay, I gotta find this ABCD.
Where's Pappuccino? Pappuccino?
Yeah, 2x plus 1. E to the x over 2. We got intersections.
Reading, good for Messner.
Elijah, sorry for yelling at you earlier. I was really just joking. Okay. We got a C and a D. Cool. A to C or B to D. We're spinning this around the x-axis. We understand I'm going to be going from A to C. I understand I have a hole. I have a washer. It's very important to understand the washer that you have. How, yes, we have an H and a DX. If we think about a vertical rectangle, come on, Betsy. I just don't like one. Let's goes back to this. Okay. We have an h and a dx, but a washer is an r squared minus r squared, which means we have to split h into kind of some of the characteristics that give us a big R versus the little r. It's right there. Come on. Sometimes, man, this computer. Oh, come on. Sorry. Look at this. Yes, come on. Freaking best performance then. Speed up, dudes. Been working this computer too hard here. Gosh. Take two. Turned off my slate. Turning my slate back on. It's really, I bet you this.
I still need the diagonal one, but I have the front facing ones.
Beautiful. Oh my gosh, it fits so perfectly,
I
Sydney.
know, and it fits so perfectly in the appearance too. That made me excited. I like that one. I was like, yay.
Good job.
Yay.
Really good.
I have the diagonal one. I put it a little bit too big, but it's like comes in from the side to the diagonal, but it's
Great.
like pretty much done.
That's awesome, Sydney. Good job.
Oh,
Hope
thank
you're
you.
having fun making
Yeah, I
this.
love it. Yeah, if you have anything else you need, just like let me know, and I'd love to make it.
Will do. Thanks. So we got these h's dx, but when I spin this region, I can see this object has this hole. When I think a hole, I think a washer. When I think a washer, I realize the formula for the washer, which is this rectangle being spun, is not pi h squared, where h is a top minus bottom. No, it's going to be a pi outer radius squared minus an inner radius squared. And we just have to understand the outer radiuses and the inner radiuses. I know I'm going from A to C. To understand the outer radiuses, I can see that the outer radius kind of goes all the way through, all the way to the bottom, and it's just going to go to the top. So my outer radius will be this 2x plus 1 minus 0. And then my inner radius comes to this bottom. The inner radius is the e to the x over 2. So as long as I have super R, it's not super R, it's just big R. And the big R is 2x plus 1. Then I have the small r, which is e to the x over 2. I'm good. That's my answer, 246.260. If I spin this around the y-axis, okay, it makes sense. Draw it over here. And I would be spinning this horizontal rectangle that has this width and this height. I can see we have dy. But when I spin this, it creates this horizontal washer. Again, this object has a hole. When you have a hole, you have a washer. When you have a washer, you have the formula of the volume to the outside minus the volume of the inside. So you have the outer radiuses squared h minus the pi inner radius squared h. So I'm going to have outer radiuses minus inner radiuses here, dy. I'm going to go from, first one was A to C, so B to D. And now I just have to understand my radiuses. Well, we can see there are these x distances. I can see the outer radius goes all the way to x equals whatever this equation is solved for x. Done this before, ln y times 2. So I'm going to say this
How you doing
is...
this semester?
What's up, though? How are
Nothing
you,
much.
bud?
Oh, you're doing this homework?
Yeah, bud. Jump on board. You
Yeah.
think you understand it?
Definitely doing that. No,
I'm
actually,
not going to see you until next
actually, well,
Wednesday.
I know it's insane. I'm gonna like really lock in on these next.
All right. And make sure we go from B to D. And we got 123.424. It's little things you can make mistakes on. Having blue eye. What up, Cash? Making sure you have B to D. And great. Now, what we got to towards the end of class is spinning things around different lines. If we spin this around y equals 11, we can see again washer, so it's again the r squared minus the r squared. But you got to understand, what is those outer radiuses? Well, the outer radiuses is centered at 11, and it goes all the way to actually the bottom of this height. So it's a y equals 11 minus a y equals e to the x over 2. I have dx instead of dy because the orientation of my rectangle is h dx. So I'm going to sum up pi outer radius squared minus inner radius squared dx. I'm going to do it from a to c, and I'm going to make sure that my inner radiuses are also known. My inner radiuses come from here to here, but half of that, the inner radius, would be 11 minus 2x minus 1, 2x plus 1. That in parentheses to 94.218. Spin this around, x equals 5. Okay, great. As long as you understand, we should be taking something horizontal, spinning it, that we have a washer, then you need to understand the radiuses to the outside of the washer. So there, and the radiuses on the inside of the washer, which is there to there. We should be good. Now I realize that the radiuses are this x distance. We go back to x equals y minus 1 over 2. And we go back to 2 log y. This is x equals 5. We can see I'd have an outer radius squared minus an inner radius squared dy. Make sure you understand where this comes from. I don't think I did a good job making sure you understand that formula, where it comes from. We're going to go from B to D. We have dy, as it's a horizontal. I have 5 minus the y minus 1 over 2. And I have 5 minus the 2 log y. 122.248. Ooh, this is a good one. Spin this around y equals 6. If I spin this around y equals 6, I create this object. I should realize that this rectangle being spun creates a solid. It's not a hole, it's a solid. Since it's a solid, it's just pi r squared h, or pi r squared dx, or pi r squared dy. Which means the radius is actually going to be h. So the height of this rectangle is 6 minus 2 root x. It's y equals top minus and y equals bottom. And I would sum these up. I'm sorry for having all these things here. You know, look at this. From the x equals left to the x equals right. Those intersect at 9, 6.
Hey guys.
So we're going from x equals 0 to x equals 9. I'm going to sum up pi r squared dx. I'm going from 0 to 9. And I now have a radius of 6 minus 2 root x. Sometimes it's dangerous putting too much stuff down. 169.646. Spun this around the line x equals 9. This would be x equals 9, which means I got a hole. And since I have a hole, I need a washer. Take this horizontal guy, spin it. We have a washer. Since we have a washer, we have pi outer radius is squared minus inner radius is squared dy. What is the outer radius? Well, you're going to go all the way. Halfway would be this. This is x equals 9 minus x equals 0. The outer radius, again, this will be from 0 to 6. The outer radius is always going to be 9. The inner radiuses will be going to that. It's an x equals right minus an x equals left. I'll do x equals middle minus x equals left. That's y squared over 4. If we solve for x, divide by 2 squared, y squared over 4. So the inner radiuses will be 9 minus y squared over 4. I will sum up from 0 to 6. D pi parentheses outer radius is squared minus inner radius is squared. D pi 712. Why is this one harder? You gotta understand that this is a combination of a solid and a hole. Look, if I'm talking about here with this height and this dx, it's good. We got a solid. Solid. If I then continue on, I realize we then have a washer. Cool. So I would have to do 2. This h is an r, but then I'm going to have to add from 2 to 4 a biggest radius squared minus a smaller radius squared. Thank you so much. So I'll call maybe this R1 and this R2. H is root x, which is R1, but root x is also R2. Root x is also super R. Notice, like, it is everything. It's always going to the outside. And then R2, the tiny R2, is going to be the x minus 2. Very interesting. Like, think about this outer radius. The outer radius is the root x. The inner radius is the y minus 2. Cool. So I got 2 integrals. Let me just clear it off. Tired. Okay, there. The first integral I really could say I have the big R. Big R is root x. Second integral, I have the big R, still going to root x, but I'm subtracting the smaller r. The smaller r is x minus 2. And I get this plus this to get my answer. Cool. There are other ways to do it. You could have actually said, well, let's just take the entire object from 0 to 4 and let's just subtract the whole from 2 to 4. Get the same answer. All different ways to do it. Just see if you can do it. 16.755. All right. Happy Pesach. Happy Easter. I'll see you guys in a week. Peace.